8.5 Properties of Logarithms. Learning targets today: expanding log functions, using log properties, condensing log functions, using log properties, and evaluate log functions using log properties. If you recall, we have some exponent properties. Remember, if we have b to the u times b to the v, the result is b to the u plus v. Now notice we have a sum, and the corresponding log property also has sum. Alrighty? Quotient property along the same lines, if I have b to the u divided by b to the v, then I end up with a difference of my powers, and that leads to this property here as far as the log property. Remember that powers and exponentials and logarithmic functions are inverses of one another. Now, if I have a power to a power property, if I have b to the u and raising it to the nth power, then I'm going to have b to the u times n. And that's really what's going on right here. That is actually multiplication. So these are the log properties, but they're related to the exponent properties. Now, one of the typical type problems we'll have is given some log base information, these are approximations, that we'll be asked to expand a log expression. So in case of example 1, I can write this as log base 9 of 5 minus the log base 9 of 11. Just using this quotient here and making it my subtraction. Now I know that I'm going to have 0.732 here, I'm going to have 1.091 here. When I calculate, I do get negative 0.359. So I have evaluated using a log property. Example 2 here, this really equals the log base 9 of 5 times 11. And again, the reason I want that is because we want to use 5 and 11. And again, since this is a product, I can use the sum property and set it up like this, which this equals again 0.732 plus 1.091, and we get approximately 0.1823. Similarly here, I'm going to think of this as I could go 5 times 5, or I could go 5 squared. Our log property in this case, I bring that power out front and rewrite the log without the power. And I could go ahead here, and this is this 0.732, so I do get 1.464. So these are using log properties, some expanding, and then evaluating. These are algebraic versions of what we just did. We are going to expand these. I'm going to think of this as log base 5 of 2 times x to the 6th. Since I have a product, I can write it as a sum. And I'm going to put the power in front. So I did kind of a double property here. The plus for the multiplying, and the 6 out front because of the power. Similarly here, I'm going to go ahead and think of this first of all as log base 2 of 4x to the 1/2 power. Remember, a square root is the same as 1/2 power. So now again, I'm going to go ahead, I'm going to put the 1/2 out in front of everything here because everything has that power. I'm going to go ahead here and rewrite my product as a sum of 2 different logs. Yeah, and we could leave it like this, or we could say, hey, I've got 1/2 log base 2 of 4 plus the 1/2 log of log base 2 of x. Now this would be fine, we could maybe simplify this numerically, but let's just leave it in expanded form here. Example 6 is using the natural log instead of a log base 2 or a log base 5. Remember, natural log is log base, the natural number, Euler's number. Now here we got a lot of stuff going on. We've got a product in the top with one of the pieces having a power, and we have a powered expression in the bottom. I'm going to go ahead and do this all at once here. So I'm going to go ahead, I'm going to have the natural log of 3 plus 4 times the natural log of y, that takes care of the top, and then divided by, so that means I'm going to subtract, I'm running out of room here, so I'll subtract 3 natural log of x. So I have a 3-parter here, my 3-part, my y to the 4th part, and my x to the 3 part. So I'm just going to write it like this here. Now the opposite of expanding is condensing. So we'd like to go ahead and condense these. First thing I like to do is with these this 2 up front, I can put it here, and with this 5 here, I can do that. So I'm rewriting using my power property of logs. And now I've got subtract, so I can go ahead and say I've got log base 3 of 7 squared divided by the log base 3 of x to the 5th. And we're done. It's a little more complicated here with example 8. I know I'm going to have this power coming up here, this power going on to 6, and this power going on to 4. Now it looks like I have a quotient within a quotient here because the 2 subtracts here. So here I go, log base 5. I'm going to have a quotient and then a secondary quotient. On the top I'm going to have 81 to the 1/4 power. Here I'm going to have 6 squared. And at the very bottom I'm going to have 4 to the 1/2 power. Now we can do all sorts of simplifying numerically here. 81 to the 1/4 power is 3. 6 squared is 36. 4 to the 1/2 power is 2. I can go ahead and these can simplify to be 18. So overall, I'm going to have log base 5 of 3 on top, 18 on the bottom, 1/6. So that one really got quite a bit different looking from the original form here. Back here to example 9, first step, 1/2 power. I've got a sum, so log base 3 of 2 times y to the 1/2 power. And we are done. Finally here, kind of a revisit to change the base formula. So again, we've done this in the past, so this is just common log of 12 divided by the common log of 7, which comes out to be about 1.28. Over here is the common log of 9, or the common log of 6. And we could replace the common log with the natural log if we so choose. We'll get the same answers. We have this. And over here we have the common log of 32 over 3 divided by the common log of 5. Okay, and we'll calculate that here quick. And be careful when you calculate these, you use the parentheses properly here. And the common log of 5. You should get about 1.47, if I did that correctly. That's it, just kind of a final here. Here were our learning targets today. We did some expanding, we did some condensing, and we did some evaluating throughout the notes here.